Good day. Welcome to another series of Chemistry Just Got Easy. Today we are going to be talking about the shape of water molecule. As we all know, water is a universal solvent and water has the chemical formula of H2O. Water contains 2 atoms of hydrogen and 1 atom of oxygen. Now, what is the shape of water molecule? The shape of water molecule is angular or bent, or you say V-shape. But how do we come about the shape of water molecule? We are going to be learning about that in this class. Let's move on to the lecture. Now we said water contains 2 atoms of hydrogen and 1 atom of oxygen. Hydrogen has just 1 electron in its outermost shell. So 2 atoms of hydrogen, that means each hydrogen has 1 electron, and oxygen has 8 electrons in its shell. So let's draw the atomic structure for hydrogen. Now, to draw the atomic structure of hydrogen, for the first hydrogen, the atomic structure is going to be equals to this. And you have this as the atomic structure of the first hydrogen. This sign here indicates the number of electrons, and this circle indicates the first shell. So this shows that the first shell is not stable, that the hydrogen atom is not stable because it is not obeying the 2-8-8 rule. That is, the first shell must have 2 electrons to be stable. Let's draw the second atomic structure for the second hydrogen. So we have this. So both hydrogen has 1 electron in their shell, which is not stable because they are not obeying the 2-8-8 rule. Then let's see for oxygen. In oxygen, it has 8 electrons. Now let's split this into the 2-8-8-18 rule. For the first shell, which is going to be the K shell, you are going to have 2 electrons. For the second shell, which is going to be the L shell, subtract 2 from 8. You are left with 6 electrons. So let's try to get the atomic structure of oxygen. So you have this. The first shell, which is the K shell, 2 electrons. The second shell, which is the L shell, 6 electrons. One, 2, 3, 4, 5, 6. Now let's see. Oxygen obey the 2-8-8-18 rule and the first shell, because the first shell of oxygen has just 2 electrons, which is the K shell. And the second shell of oxygen, which is the L shell, you have 1, 2, 3, 4, 5, 6, which is just 6 electrons, which does not obey the 2-8-8-18 rule. Because for oxygen atom to be stable, it needs 8 electrons. So what happens is that in the formation of water, each atom of hydrogen, that is 2 atoms of hydrogen, combines with 1 atom of oxygen. So you have, I'm going to be drawing them now. The first hydrogen, the second hydrogen, combining with oxygen. To give water. Now let's see how they form the water molecule. Now you have, let's first draw the oxygen atom. So you have the first shell of the oxygen atom having 2 electrons. You have the second shell of oxygen atom. Now we can see that for the first shell, for the first hydrogen, it is not stable because it is not obeying the 2-8-8-18 rule. The second hydrogen atom is also not stable because it is not obeying the 2-8-8-18 rule. And oxygen atom too is not stable. Now, the Each hydrogen atom needs one electron more to be stable, and oxygen atom needs 2 electrons more to be stable. Since the number of electrons needed by each hydrogen atom is stable, to be stable is 1. So what they simply do is they actually bond with oxygen by sharing 1 electron with oxygen. And this kind of bonding, in which atoms share electron with each other, is called covalent bonding. So let's see how it goes. So this hydrogen will come to oxygen and share 1 electron with it. So you have this hydrogen coming with its own electron, its nucleus, and then it has shared this electron with oxygen, and then oxygen is also sharing 1 electron with it. Now let's see the number of electrons present in this atom of hydrogen. So you have 1, 2, which is 2 electrons, which shows that this hydrogen atom is balanced. Then the second hydrogen will also come. Then it will share 1 electron that it has with oxygen. And oxygen will also share 1 electron with it. So let's count the total number of electrons in the second hydrogen atom. 1, 2, which shows that both hydrogen atoms are balanced. But for oxygen atom, it shared 1 electron with this hydrogen. Remember, we have 6 in the second shell, so 6 minus 1, 5. It also shared 1 more electron with the second hydrogen. 5 minus 1, 4. So it is left with just 4 electrons. Now let's put down the 4 electrons. So let's try to count the total number of electrons on the second shell of oxygen atom. 1, 2, 3, 4, 5, 6, 7, 8. We can see that the total number of electrons on the outermost shell of oxygen is complete. So we can have the shape of the water molecule that is formed, because we can see here we have 1 atom of oxygen and 2 atoms of hydrogen, which is water molecule. So let's see. Oxygen shares 1 electron with the first hydrogen, so a single bond. It also shares another 1 electron with the second hydrogen, which is a single bond, and it has 2 pairs of lone electrons. So you can see why we say the shape of water molecule is angular or V shape, and the type of bonding in water molecule is covalent bonding. Book the ALC tutors for your personalized online chemistry class at an affordable price. Follow the ALC tutors for daily chemistry content. Follow, like, and share. Bye. See you next time.